there's not much I have to tell you. If you remember when we did I had the family tree up here, right? You had the rectangle, and then you had the rhombus, and then what came off both of them was what I refer to as the golden child, the square. And the reason why it's the golden child is it's got all the properties. Parallelogram, rectangle, rhombus. That was a lot of properties we listed up. Square's got them all. Every property we discussed so far this unit, the square has. So why do I only have 2 properties listed for us to fill in? Here's why. Number 1's going to be all rectangle properties. Square has. Okay, all rectangle properties. And then the second one's going to be all rhombus properties. Why don't I have a number 3 up there that says all parallelogram properties? Because that's true. Why don't I need that? Yep, so
rectangle and rhombus already.
They're already in there, right? Rectangle and rhombus, the parallelogram properties are already in there. Okay, so that's what a square is. It's got every single property. So knowing that, I just want you and your group to take over here for this next problem. I don't want to say a word. You got a square. Length of a diagonal is 16 units. Remember, diagonal connects 2 vertices, non-consecutive vertices. That diagonal length is 16. What's the perimeter of the square? All right. Again, guys, you have every single property you need to use if you need it. Perimeter of the square. So what do all sides added up equal, right? All sides added up. So I'm going to let you and your group talk it over. I will give you a hint to the answer. I'd like the answer in radical form, not decimal form. So you should have a radical in your answer at the end here. All right. Should not be a whole number. I want it in radical form. So you and your group, get after it here. All right. You can add to the diagram if you want to. It's up to you. All right. Square's got every single property we've talked about. Find me the perimeter. Go ahead. Give you plenty of time to talk it over and hash it out with each other. And your answer should be in radical form. So what else do we know is true? Can I add different pieces in? But I need to find what all 4 sides add up to. And if you know one side of the square, you know them all. It is okay to talk it over with your groups. If you want to add anything to your diagram, keep whatever I gave you.
Oh wait, does that has it? This is a right perimeter. So if you have one side is 16. I taught you 16, so that's the square. And she's like, okay. She's like, 30. Okay. Oh yeah. So we don't have to do it.
Yeah, personally, I just use this at 16.
I got
32 plus x squared equals 16. I have to think about it.
Wait, did you make that finish?
It literally works. Trust.
Okay, hold on. So x squared plus h squared z squared.
I don't know.
It's 8 square root 2, and then the
I got 8 radical 2.
yeah, don't we have to add up the whole one? To find the perimeter from like
Oh wait, no,
You
no,
found
we're
one
doing
side.
so it's 8 radical 2 times 4.
no,
Okay.
it's just like 3
4 times
32 radical 2.
$32.
What kind of triangles?
I'm getting overthinking it.
Triangles?
How did you do it then?
Okay, let's talk about this. To make it easier for me to describe this, I'm going to add in the other diagonal too. All right, because when I add in the other diagonal, here we go. When I add in the other diagonal, a lot of properties going on right now. Both of those diagonals are the same length, 16, 16, because that's a property of a rectangle. Diagonals are also perpendicular. They also bisect each other, which tells me I got 8s all across the board here. Why is this helping me out? Well, take a look. This is a right triangle. And how many sides do we know? 2 sides. We got a little device we've used all year long where if I know 2 sides of a right triangle, I can find the third. Pythagorean theorem. Where A and B are your 8s. And C is going to be the side of the square. So I keep plugging along. 64, 64. Add them together, you get 128. And now you go to your calculator, take the square root, and I mentioned please leave your answer in radical, not decimal form. And one side of the square is, I believe with your calculator, it'll give you 8 radical 2. What's one side, not the perimeter, right? Not the perimeter. Perimeter I'll get by either adding 8 radical 2 4 times or multiplying it by 4 because all the sides are the same. So in radical form, your perimeter is 32 radical 2. Okay? 32 radical 2. Questions there? It is nice to hear, right, that all these properties are available to you, but then the drawback is which ones do I actually need, all right, out of all these properties. All right. I want to make sure we go over another coordinate proof. Make sure we're solid there here. So go ahead. And then I'm going to start asking a bunch of questions to you guys. Just take your time graphing, right? Because if we don't graph right, we're toast from the beginning. All righty. First job, prove this bad boy's a rhombus. So let's go back to yesterday. How do we show on a coordinate proof that any quadrilateral, because we only had one way. I know I had multiple options listed, but we were like, no, we're only doing this one way. So how do you show me this is a rhombus? What do I have to do here? How do you show this figure is going to be a rhombus? All right, let's roll. Jonathan, how do I show it's a rhombus from yesterday's notes? It's the one big property of a rhombus, too. All sides congruent. All right, which means in step 1, what formula am I going to need to use to show they're all congruent, Drew? Distance. All right, everyone ready? So in step one, we're going to show the distance of all four sides. Good news, though. I don't need the distance for two of them. You don't need to do the distance formula for AT and MH. Any idea why I'm not going to require that? It's a waste of time. Why, Bailey? If you can count, you can do it. Right? If it's a horizontal or vertical line, just count the darn thing. I don't need to see distance. Right? Hey, AT, 1, 2, 3, 4. It's 5 units long. Have a good day. Right? So don't waste your time doing distance if you can count. And same thing for MH. You can go ahead and count MH. It'll also be 5. Now, though, yes, I am going to need to see you guys plug in numbers for AM and TH for me. And this is why I think you guys should have an easier time with these proofs versus statements reasons. You know it's got to come out to be 5. So as you type these numbers in your calculator, and when you hit enter and it doesn't equal 5, user error, right? Something went wrong. User error. We plugged some number in we shouldn't have. So change in x's squared plus change in y squared. Plug them all into your calculator, and hopefully when you press execute, we get a 5 spot back. And we're all getting 5, hopefully out, okay? Again, if not, you guys got to look back and make sure you're plugging in the correct points together. All right, you're subtracting the correct numbers. So we showed all the distances were 5. Step 2, what did you just learn from step 1? And it's a rhombus. We're not there yet. What did you just learn from step 1 that we're going to write down in step 2? 1-7. Dylan, what did you learn?
All the side lengths are
Okay, so show me that. AT, congruent to MH, congruent to AM, congruent to TH. You can put them all in one line since they're equal to each other. And then tell me why. How do you know they're all congruent? Here we go. Zoli, how do we know?
All sides are equal.
I know that. That's what I just wrote. Right? How do we know based on our work in number 1, how do I know all 4 sides are equal? What did we just show in number 1?
The length of the sides are equal.
Okay, because distances are equal. And I know this class pretty well. Let's keep this organized and neat. Not all over the place. I shouldn't need a road map to follow your coordinate proof. All right, now that all 4 sides are equal, you guys told me that's good enough to make this a rhombus. So math is a rhombus. I just need somebody to give me a good because statement. Why is this a rhombus now? Because, here we go. Stephanie, why is it a rhombus? Going back to your homework questions here. Done. Because all sides congruent. Rhombus is one of the easier ones to prove. And there's a second part. Yeah, prove to me it's a rhombus, but now show me it's not a square. All right. So, all right, what's a square have that a rhombus doesn't? One big thing. Right angles. So if you could show me, I don't need to see all 4, If you could show me one of these four angles is not a right angle, it cannot be a square. Agreed? Cannot be a square if one of the, you don't need to show me all four, just one of them. So let's make a class decision right now, or somebody's going to make a class decision. Stephanie, pick an angle that we're going to show it's not a right angle. Okay, everyone, T. Let's show angle T is not a right angle. How do we do that? Well, it doesn't look like one. Yeah, that's garbage. You can get out of here if you're going to give me that response. How are right angles formed if the lines are? Okay, show me AT and TH are not perpendicular. What formula am I going to need? Slopes. Yep. So we're going to do the slope of AT and we're going to do the slope of TH. And hopefully they are not negative reciprocals. Because if they are, we're in trouble. All right, AT. That's a horizontal line. There's no rise over run here. Just going to be 0. All right, the slope of any horizontal line, 0. Vertical's undefined. All right, somebody to go ahead and do TH. Do a little rise over run like we did yesterday. All right, I only want you guys using rise over run to find the slope. Up and over how many? Or down and over how many? Slope of TH, when you have it there, slope of TH, Jonathan? Negative 4/3, good. Make sure it's negative, everyone. And now, all right, just like we did with steps 1 and 2, step 4 and now step 5, what do you know now about AT and TH? Well, I guess we know a couple things, but only one in particular, that they're not. Yeah, oh yeah, and hey, I know you're going to feel like a bunch of badasses doing this. Ready? Yep, perpendicular. Yeah, go ahead, make that slash through it. Yeah, hardcore in here, aren't you, kids? Yep. Because how do we know they're not perpendicular? Tess, how do we know? And use the work we just did from number 4. What did we show in number 4?
Because
Usually when they are perpendicular, what do we know about their slopes?
negative reciprocal.
And what do we not know here now?
They are negative.
Done. Yeah. Yep. Good. AT not perpendicular to TH because slopes are not negative reciprocals. And good work. Guess what? This thing's not a square then. Math is not a square. How do we know that? I'm looking for some good wording here. Why is this not a square? Because, Simon, in your best wording, why is it not a square?
It doesn't have rectangle properties.
What's that?
It doesn't have the properties of a rectangle.
Which one in particular, though? That's what I'm looking for. What did we just show here? That because AT and TH aren't perpendicular, it doesn't have a?
Right.
There we go. Math is not a square because it does not have, and I'm not going to say it does not have a right angle because it still could, because we only tested one. We didn't test all 3, right? So we're going to say because it does not have 4 right angles. We definitely know that's true. All right, don't say it doesn't have a right angle because the other 3 could possibly be one. Right, take a quick breather here, stretch if you need to, because we're done finally with that left side of the family tree. We got all that done. Now we head over to the black sheep, the right side, the outcast, and start talking about the kite. If you remember why the kite was all by itself, no sides parallel. No sides parallel in a kite, but there are 4 properties. Oh, here they come. All right, we had all the parallelogram properties. Now here come the kite. Get them straight. Get them straight. First property is what's shown on the diagram already. 2 sets of adjacent sides congruent. There's a kite. But the opposite sides aren't, right? The opposite sides are not congruent. They do have 2 sets of adjacent congruent sides, but the opposites are not. All right, do me a favor. Can you guys just draw in diagonal BD for me? Draw in diagonal BD and do not make any other markings. Draw in diagonal BD only. I'm going to make a couple more markings after I ask you a few questions, but just leave that diagonal on your diagram. What type of triangle did you form with ABB on top? Thank you. Isosceles. What's across from those congruent sides? Congruent angles. Just let me mark them, please. On the bottom, you created triangle BCD, which is also what's across from those congruent sides? All right, don't mark them. Let me mark them. Now, does everyone agree by addition, all of angle B is equal to all of angle D? Can we agree on that? Yes? Okay, so here's property number 2. One pair of opposite angles congruent. Not both, just the one. And the key is knowing which pair. Okay, which pair do you pick? Here's how I always remember it. I always know it's the angles in between the non-congruent sides. All right, so if you take a look, here are the two non-congruent sides. They meet at angle B. Here are the non-congruent sides. They meet at angle D. Okay, so the congruent angles are always the ones formed by the non-congruent sides. Draw in the other diagonal, AC, please, on your diagram. Go right ahead. So you should have diagonal BD and diagonal AC drawn. I never have you do this, assume, but this is the one opportunity all year. I'll let you assume. What do you think you know about the diagonals just by the looks? Perpendicular. Yeah, definitely not congruent. All right, diagonals are perpendicular in a kite, which means they form a nice 90-degree angle. And when you were drawing in diagonal AC, the fourth property was happening as well. All right, when you drew in diagonal AC, the fourth property was happening as well, which is the longer diagonal. Anybody want to finish it based on the markings I put here and here? What the longer diagonal does to the shorter one? Beats it up pretty good. Yeah, longer diagonal bisects shorter. It's not the other way around. They don't bisect each other. That's a parallelogram. Just the longer diagonal bisects the shorter one. Whew, 4 more properties. Just threw them at you. Lasered them at you. All right, let's do number 1 together, and then 2 and 3 are in your groups to finish off class today. All right, we got a kite here on number 1. I gave you 2 out of the 4 angles. First, using your properties, what do we know about angle 1 and 2? Those are the one pair that are. Because, take a look, it's always the angles that connect the non-congruent sides. Those are always the angles that are equal. So right away, whatever our answers are going to be, they're going to be the same. Because angle 1 is congruent to angle 2. Now we got to get them. I know it's a kite. It still has how many sides? Quadrilateral. It's still a quadrilateral. What are all those angles going to add up to at the end? All right, there you go. Let's get to work. We know angles 1 and 2 are congruent, and all 4 are going to add to 360. So let's get to work finding angles 1 and 2. $105.5 degrees for each. Yep. All right, I'm going to let you and your group take over now with the next 2. Remember, when you draw the shorter diagonal in, you create two isosceles triangles, one on top, one on the bottom. There's 180 degrees in every triangle. Okay, use some other, if you can't find any kite facts to use some other facts, some geometric facts, all right? So go ahead, talk it over here, talk it over. Anything goes, just doesn't have to be a kite.
Two is 63. 27 plus 90 and 180 minus 117 is 63. Oh, because
It makes it right.
yeah, and I saw some of these. Yeah. So we should have to find X.
Make that 8x equal 8x.
I don't know. Is 8x the angle measure? Yeah. Which angle measure is it?
Yeah, which angle measure is that? Oh wait, no, we don't have to do that. It's 5x. 5x minus 1 plus 8x plus 90 equals 180.
Minus 9. Plus 9. Is that right? And that is
That's the angle of the side. Oh. But isn't the side it said it's not bigger diagonal, that's just the small one, so I want to have
If we both get one answer, we will both do. Oh, it's minus 1.
That's the problem. I can speak. I just thought
I got
that was like the
seven.
size. Junior was like, so you should be. So I just did that.
I did too. But that's not correct.
Did you get 12x equals 91?
No, 13. Plus 5. How did you get 12?
I subtracted the 90 start. And I subtracted the 1 from 90 that was in.
Oh, you did it both ways.
Well, that's
Oh.
5 plus 8 is 13.
trying to figure out one.
Wait, probably why.
Are you thinking that one is?
Sorry, I was right.
Yeah.
Oh, I got it.
13. Oh, yeah. So these two plus.
For number 2, angle 1 should have been 90, no big deal, diagonals are perpendicular. Angle 2 and angle 3 are congruent because, again, you form an isosceles triangle up top, and across of the congruent sides are angles 2 and 3, congruent angles, which should have been, 63 degrees? Okay, 63 and 63. All right, now a lot of some confusion with number 3. You know, what do you set up to solve for x? Well, again, this is a right angle. Diagonals are perpendicular. Still an isosceles triangle on top. So if that's 8x, that angle right here is also 8x across of the congruent sides. Now you see I have a triangle here where I know 3 angles already. One way to do it. So I got the 90, the 8x I just wrote in, and the 5x minus 1, which was given. And they all equal up to 180 because they're all in a triangle. That, again, one equation you could have set up. I'm sure there was multiple ways you could have done it, but x equals 7 here at the end. After you solve it, x equals 7. All right. I am not going to do the next coordinate proof with you. I want you to start on the assignment for tonight, all right, to get practice with some algebra stuff now. We'll get back to that one if we have time later in the future. So start the assignment.